Hi there, Freddie. It's Noah Millman. Write for the American Conservative and also for other outlets, but that's my main home. I've been looking forward to this belonging heads for a while. You want to introduce yourself?
Yeah, me too. My name is Freddie deBoer. I've recently completed my PhD in English at Purdue University, where I studied writing assessment and applied linguistics, and I write for a few different places, including my own website.
See, you have actual credentials, right? You've got a PhD and you've got, an academic job, and I just, I write in spite of having absolutely no particular legitimate basis for anything that I say. So I don't know
Well,
which.
yeah.
I don't know whether that's better or worse. It certainly makes me a little
Well,
bit
I want to.
daunted to be having a conversation about some of these serious technical topics that we've teed up, given that you may actually know what you're
Well,
talking about.
yeah, you shouldn't be daunted. I mean, one of the things I want to stress to the people watching at home, and if I didn't stress this,
Assuming
I'm
there
sure
are
some of the
any.
commenters would. Right. If I didn't stress this, I'm sure some of the commenters would. But in a lot of the sort of areas we're going to be talking today, I consider myself an amateur. I am sort of a passionate and informed amateur, particularly when it comes to things like artificial intelligence. But I am an amateur, and to sort of kind of give a little bit about my background. I mean, I came from a very sort of traditional humanities background. I grew up in a house sort of filled with the arts, and I got my bachelor's degree in literature. And then in my master's program, my advisor, Bob Schwegler at the University of Rhode Island, was someone who's doing a lot of really interesting empirical work. So some of his work, for example, involved the use of eye tracking because he studies student writing like I do,
Mm-hmm.
and he used eye tracking to sort of study how sort of visual patterns of people who are composing and comparing it between first language and second language students, things like that.
Gotcha.
So I sort of became interested in questions like this, and it became clear that I had to develop a quantitative skill set to answer some of the questions that I wanted to. And so in my master's program, in my PhD program, and on my own for the last 5 years or so, I've been pursuing sort of educating myself in statistics and in corpus linguistics and natural language processing and things like that. And it's like and I can, I'm still a beginner in many ways at sort of quantitative stuff. I am learning a little bit more every day. More and more of my own work, for example, I'm coding my own stuff in the programming language R.
Mm-hmm.
And a lot of these sort of techniques that I'm using dovetail with questions of artificial intelligence. So typically, my research involves using programs from corpus linguistics, which is the study of large collections of texts at a time, or from natural language processing, and looking at large collections of real-world student data and mining them for their patterns, their statistically identifiable patterns, and then hopefully making intelligent observations about them so we can sort of direct pedagogy and
Right.
administrative work.
I'll
But
say a
all
little
that
bit
said,
about sort of why I'm interested in some of these same topics that you are. I'm
roll.
a somewhat less informed, or actually substantially less informed amateur, is how I describe myself. Um, but I'm also somebody who has historically had kind of a foot in both camps between the world of sort of the arts and humanities on the one side and the world of science and mathematics, I guess, on the other side. I studied history in college, and then wound up working on Wall Street for a quant shop for many years, and I was kind of the guy on the desk who knew how to write, and who also could have intelligent conversations with the people who actually were PhD mathematicians or physicists, not intelligent conversations involving formulas, but sort of understanding what they were getting at. Um, and in terms of the stuff that you're doing specifically, I'm interested in that from the perspective of talking about sort of the big data approach to education, and the ways in which sort of education reformers have been correctly or incorrectly using the idea of sort of data intensive approaches to pedagogy. as opposed to what you might call sort of more classical approach or a more progressive approach, neither of which are particularly data-intensive approaches. But we're sort of jumping down the line, I guess. I know that you have a sort of a line that you sort of want to lay down a little bit on artificial intelligence, and a line that, if I understand it correctly, is derived from Douglas Hofstadter. I remember reading his book for the first time when I was a kid, and skipping over all of the difficult parts and pretty much just reading the dialogues, and then going back to it as an adult and reading all the tough parts as well. So I have some idea of where he's coming from. And I understand a little bit about the differences between the way he thinks about what artificial intelligence ought to be and what people are actually pursuing in both in academia and in the business world with Google and so on and so forth, using big data to solve problems by brute force. So do you want to talk a little bit about that and then dive in from there, or do you want to start from a different direction? Or
no, that's fine. Yeah. So again, I just want to make the caveat that for the people watching at home, I am approaching this as a dedicated and sort of passionate amateur. I'm someone who reads a lot and works hard to be informed about artificial intelligence. Mostly, I'm reading it from sort of popular sources. And I've read Hofstadter's book, and I've done. Hofstadter, we're talking about Gödel Escher Block, and it's a book that is a project in like a really direct sense. I mean, constantly Hofstadter is saying, here's a mind experiment you need to do in order to understand what I'm saying, so really do it. And I've read his book a couple times, and I've read most of Peter Norvig's big textbook. He's the Google artificial intelligence guru and one of the sort of the gods of probabilistic AI right now, and a lot of articles and things like that. But again, this is coming from the perspective of someone who just wants to be a better amateur to continue to develop his sort of ideas about this. But so from that perspective, the traditional idea of a human-like artificial or computer intelligence was considered to be quite easy when people first conceived of it. And of course, it's proven to be a notoriously difficult problem. And again, so the idea is that you create a computer system that thinks in the way that a human brain thinks, a human mind thinks. That project, depending on who you ask, is still in its infancy. And so Doug Hofstadter, who is at the at Indiana University and is just a giant in the field, is someone who will tell you that, in his opinion, there's almost no good work that's been done in that field because it's so difficult, which we'll talk about some of the reasons why. There's an alternative which has sprung up, which you see sometimes called big data AI or probabilistic AI. And the way that this functions is the way that a lot of sort of systems function right now, which is the internet has given us just the access to an enormous amount of data, and we now have the ability to process that data far more sophisticated ways and far more quickly than we would even just 10 years ago. And so rather than trying to create a model of how a human brain thinks and programming that model into a computer system, you sort of approach problems probabilistically. In other words, you look at how human beings tend to behave mentally or whatever, and then you use that using things like Bayesian statistics, which are a kind of trainable statistics. Right. And you train a system to try to react in the same way that a human being would. So
so you could almost describe that as kind of taking the Turing test, right, teaching to the Turing test, right? If the Turing test is, we'll know that the computer can think not by what it's doing inside, but whether it can fool us into believing that it's thinking, right? So you say, okay, well, then we'll teach to that test if, we'll have the computer continually do a particular task and correct it as it doesn't do it sufficiently convincingly like a human until it has learned to do it like a human, and then by definition it's fooling us into thinking it's thinking.
Right.
But we have no idea what's going on the inside, or if there's anything going on the inside.
Right. So a perfect example is a machine translation, like Google Translate, right? You have access to, these days, many people, and you have access to many translations produced by people. So you take a chunk of language and you say, okay, how does a native speaker of Italian who also speaks English, translate this chunk of Italian into English? And you add that to your model automatically. And another person translate that same section or something very much like it. You add that to that model. And so you're generating more and more observations. And over time, the computer is able to say, well, X% of the time, people are translating this chunk of Italian into English in this way. So the odds are that's the correct way. Now, that's a very simplified version, and these things are quite sophisticated. But at the root of it, it's simply a matter of looking at existing data sets of how people have translated things in the past and adding them to an incrementally more sophisticated model. Now, for things like machine translation, that has proven to be quite effective, although anyone who's ever used Google Translate to try to communicate knows that it can sometimes produce wildly inaccurate answers.
Weird garbage, yeah.
Right. Why does the weird garbage happen? Well, the weird garbage happens in large part because there is no functioning sort of grammar underlying that is not part of the probabilistic model. In other words, the computer is not trying to do, what it is expressly not trying to do, is to come up with a model of how language works in human brains and replicates that. It's just trying to say, how do real-world humans translate?
Right.
And this gets... Sorry, go ahead.
So I'm gonna jump right through that to sort of a big philosophical question, right? Which is when you talk about something like understanding how a language works, are you familiar? You're implicating, I think, a question about how not just how sort of processing works in the brain, but how human consciousness is involved in that process, and so you've got an implicit theory, I think, about what consciousness is, and about what role it plays in, for example, our ability to use language. You're familiar with Searle's Chinese room paradox?
Right. Yeah. So why don't you describe that?
So this is right. You wake up and you're in a locked room, and somebody pushes, and there's a book in the corner that says, what to do if somebody pushes Chinese writing under the door, and somebody pushes the Chinese writing under the door, and you open the book and you discover there's a set of instructions of what to do, and you follow the instructions, and by following the instructions you produce marks on the paper, and then you shove that back under the door. It turns out you've been answering a question in Chinese by following this set of rules, right? So the earlier generation of AI, as I understand it, sort of tried to build that book, right? And it turned out you can't build the book as a practical matter. That language doesn't work that way. And so instead they've been trying to, for lack of a better way of putting it, sort of evolve the book in a sort of, or not really in a Darwinian fashion, but in a sort of directed sort of, this livestock breeding version of a sort of directed evolution. You keep the results that were right, and you throw out the results that were wrong, and inside the computer somewhere, a rule book is being built through that experience. In neither of these cases, right, is there even the pretense that there's anything in the machine that is a thinking being, it has the sort of interior mental life that a human being has, that anybody that we've ever met who uses language, we believe, has. And so I guess, where do you stand on the spectrum of people, what they think consciousness is, and whether we have even the first notion of what modeling that would mean, as opposed to modeling the way what we think are different sort of processing modules working in our brain might be working.
Okay, so let me use.
Does that make sense?
Yeah,
question?
Yeah. Let me use a kind of a real world example to talk about. One of the hotter applications in natural language processing is called latent semantic analysis, which is part of the broader field of vectorial semantics. And what this is it's the notion. So when we say semantic, we mean meaning, right? Semantics is the field of linguistics that's concerned with how language sort of tracks onto real world concepts. The way that latent semantic analysis works is like with many of these systems, you have a training set, like you have a set of data that has within it relationships between different words. You open up a book and there are different words in that book, and while the different words can be put into many different kinds of orders, we know that there's a grammar that underlies the language they're written in, so there is certain constraints on where those words can appear in relation to each other. And latent semantic analysis is an extremely complex set of statistical tools. It uses what's called a decomposition matrix in math, and it creates a sort of a model of how words go together based on these large data sets. And so what the computer can tell is that it knows, for example, that the word peanut butter, the term peanut butter, and the term jelly have some kind of a underlying relationship. And it can also tell that underlying relationship is different from the relationship with the word bread, even though they all have a sort of proximal similarity. And what that results in is in terms of like an end user application, latent semantic analysis can do a fairly sophisticated job of matching like synonyms from a human rater. So, for example, you sit down a bunch of research subjects and you give them a test word and then a list of possible combinations of possible synonyms. And you have those research subjects circle the word that they think is the best synonym for the one that you put down. In practice, latent semantic analysis can match those test subjects really pretty well. Now, as with all these systems...
But it doesn't have any idea what peanut butter is.
Right. So in other words, it knows that there's a relationship between different terms. And in many ways, the knowledge of that relationship is very sophisticated in the sense that it is sort of quantitatively rich. It knows all kinds of information about how these words go together, for example. But what it doesn't know is it doesn't have any kind of additional sort of cognitive understanding of what peanut butter is or what jelly is or what bread is outside of this.
They don't mean anything.
Right, outside of the system of word relationships. And so the question becomes, is that understanding? I think that most anyone would say that is a far cry from what we think of as an adequate human understanding, which is that
I would go further than that. I would say it isn't understanding at all.
Right.
That there are different layers of understanding that a human being might have, reading a text, let's say, right? And there might be reference in a text that, from context you could figure out things like, this looks like, you're translating some, ancient papyrus, and you're like, this, I think, is a title, right? This word. I haven't seen it before. But from context, it looks like it's probably a royal title of some sort, right? And that's a conjecture. You're not sure you're getting it right, but you're able to do that because you have some ideas already, some understanding of what, what kind of a document this is, of what a title is, right? The computer might theoretically be able to play the same game and say, look, odds are it fits into this box, right? Of thing, title, right? Pharaoh, let's say, right? Because it shows up in the same kind of context as statistically all these other sort of situations where you have a hieroglyph, placed sort of like this, but there won't be any meaning at all, to the statistical analysis that it did. Title
Right.
itself doesn't mean anything to the computer.
Right.
You know, the whole concept of meaning is dependent on the idea that there's a consciousness
Right.
there, and I don't think anyone thinks that, or maybe I'm wrong, but I don't think anyone thinks that computers have that.
Right.
And without that, you can't have understanding at all. That was sort of Searle's point with the Chinese room, as he said, where is the entity, and what is the entity in the Chinese room that understands Chinese? It's like, well, it can't be the book, because the book is inert. It doesn't understand anything. It can't be the person, because the person is just following rules. He doesn't understand any Chinese. Even though the person is conscious, right? The rules don't give him semantic content.
Right.
Right?
Right.
And, you know, you can say something like, oh, understanding Chinese is buzzing around the room somewhere, but that's a very unsatisfying answer, right? That's not the way understanding works.
Mm-hmm.
If I read the words peanut butter and jelly, right,
Mm-hmm.
you know, I could have a Proustian moment where I remember biting into a peanut butter and jelly sandwich and what the texture of the bread was and what kind of jelly it was and whether it got on my fingers, and like all of that can be, you know, it potentially is in there.
Mm-hmm. Right, and so when you say that, you know, that you know, this does not seem to be an adequate sort of idea of understanding, when you ask, and I think that it's accurate to say that latent semantic analysis in many ways is a very sophisticated version of a Searle's Chinese room. When people say, so, you know, where does the sort of understanding reside? There's some very sort of sophisticated people out there who will say that, in fact, it is what they call, the term of art is an emergent property of the system. So another
right. So, that's another way of saying that we don't have any idea.
Right. Well, I mean, and I don't mean to be too dismissive, because, like I said, a lot of these people are very, you know, well credentialed, very smart.
No.
But it's never been satisfying to me. The idea of an emergent property just does not seem to be sort of scientific. But what some of them say is that, you know, we don't know for a fact that consciousness resides in any particular mechanism of the human brain or sensory apparatus, and that it's possible that what we perceive as consciousness is in fact just a sort of emergent in the same sense, and that it sort of comes from all this sort of confluence of different systems working together.
Well, I think when people talk, when a scientist would talk about an emergent property in a context where it would mean something, right? It would be something like, you know, can you tell what the viscosity of a liquid is going to be from, you know, nothing but characteristics of a single atom, right, of an element, let's say, right, or a single molecule, right? And the answer is, at this point in the state of our knowledge, the answer is basically no, right? That property doesn't emerge from that unit, right? It's a property of a bunch of those molecules, right, forming a mass, right? And we can't, you know, we don't have a way of being able to say, just by looking at the chemical formula of that molecule, oh, the viscosity is going to be this, right, at this temperature, right. That's a property that only comes into play at a certain scale, right. You know, you could look at sort of weather patterns similarly, right? They're the result of, you know, a chaotic, unpredictable, fundamentally unpredictable process, you know, because it's technically chaotic, right? You know, so we can't, you know, we can only predict the weather from larger scale observations of the weather elsewhere, and even then, there's, you know, sort of inherent sort of uncertainties about it. When people say, you know, consciousness is an emergent property, I'm not saying that's implausible. I'm saying that's not answering a question.
Right. Yeah.
Right. That's just saying, okay, we won't know what consciousness is by looking at how a neuron works. We're never going to get the answer from that. Okay. But if all you know is that it's emergent, you don't actually know what it is yet. And I think sometimes, you know, I had this reaction to Daniel Dennett's book. Which one was it? I don't remember which one it was. You know, but he follows Hofstadter in sort of arguing that it's a sort of self-reflexive quality that sort of defines consciousness.
The strange loop.
What's that?
A strange loop.
Yeah, right. That consciousness is a strange loop, right? That's Hofstadter. Right. That's his insight from Gödel, and Dennett sort of follows that, And I understand what he means by that, but I don't actually think that's an answer to a question. Right. That's sort of pointing in a direction of something that might be significant, but it's not an answer.
Right.
You haven't explained how it works. You've identified that if it didn't have this, it wouldn't work.
Mm-hmm.
Which is not the same thing.
I mean, one of the questions that somebody might ask themselves is, well, if there's such an intuitive, if the probabilistic system, right? If using, if the sort of systems that are based not on trying to understand a fundamental sort of theory of cognition that underlies our thinking, but rather uses, these very powerful models and huge amounts of data to make predictions about how real life minds work. If that's so intuitively unsatisfying, then why do they predominate in so many of our systems?
They're intuitively unsatisfying as an approach to understanding the human mind.
Right.
But that may not be what they're trying to do.
Right.
Right. So, when I worked on Wall Street, right, a lot of the, it was the era when computerization of stock trading was, taking over, and we're now, basically at the point where, to a first approximation, all the trading that goes on is between different computer programs. Mm-hmm. There's an empirical argument that this, quote unquote, works, right? Because lots and lots of people are betting trillions of dollars that it works, and they continue to bet that way. That's about as good a sort of real world, proof as you can have. Does that mean that these computers, know anything about the value in some, the peanut butter and jelly sense of the underlying businesses? No, they're doing exactly the kinds of big data stuff that we're talking about, right? But they're doing something, right? That something just doesn't look anything like what humans do. Mm-hmm. If Google car, if the self-driving car, works, it's not going to work the way humans drive, and if it works at all, it'll probably be better than humans in certain ways. There may be some circumstances where it, is worse than humans. The, Deep Blue is a better chess player than any human. But it doesn't play the way a human does. It hasn't taught us anything about how humans think. It may have taught us something about how chess works. I don't know. Mm-hmm. I don't know whether it has or it hasn't. Whether it has discovered things, right? Like strategies that humans never found because they don't make sense to a human, right? It could be it could be learning interesting things about the game it's playing, right? That humans could then understand without actually doing any human thinking. So it's. I guess my question is, artificial intelligence may be a misnomer, or it may not be a misnomer, depending on what you think artificial intelligence is for. But if you want to answer the question, why is this the focus? Because it generates practical results. You can do things with it,
and whether
those things are thinking like people or not.
And those practical results lead to the economic foundations of this kind of research. So one of the things that I mean, so for context, for the last couple of years, I've worked here at Purdue in what's called the Oral English Proficiency Program, which is both a teaching and a research program. I'm actually in our research laboratory right now, and this is a program where we work with second language graduate students who come to the university, and they're dominantly in STEM fields. And these are students from China, from India, from all over the world, who need to develop their oral English skills for various academic and professional reasons. Now, working with them for years has been really a great benefit for me. One thing that I think a lot of people in the humanities and social sciences don't understand, because we never have money, but to a tremendous degree, a lot of the public funding of basic research and a lot of STEM funding in general has dried up, and particularly from federal funds, and also the job market in STEM fields is much worse than I think a lot of people understand in academia. So if you are a brilliant young computer scientist from China who comes to the United States, and you have to make a decision about what you study, it makes a ton of sense to be able to credibly say to an Amazon, right? After I'm done getting my PhD at Purdue, I don't have to go into academia. I can take my algorithm and I can bring it to Amazon and I can make your search recommendations more profitable for you. In other words,
yeah, these people, 15 years ago, these people were going to Wall Street, or 20 years ago, 25
right.
years ago, these people were all going to Wall Street. Everybody who got, when the superconducting super collider got shut down, right? There was a whole wave of PhD physicists who thought that was going to be what they were going to do, and suddenly those jobs didn't exist because the research project didn't exist. The facility wasn't built.
Right.
So they wound up figuring out how to manipulate the capital markets instead because there was money there.
Right, and and for people in the STEM fields in general in the academy, even after you get a job, the quest for grant funding is a never-ending source of stress.
Mm-hmm.
And so, here, we have people who are funded by our departments, but there's also lots of people here who are funded by agribusiness, who are funded by Boeing, who are funded by Monsanto, who are funded by the NSA and the CIA. And so having a sort of practical thing that you can take to industry or government and say, we can solve X problem with this, always makes it easier for you. And then the other side...
Yeah, and I think it's always been that way to a certain degree. I think there have been periods in history where there's been more. There have been periods in history in different countries where there's been more and less willingness to fund sort of purely basic research. And I don't know. I mean, I don't know what we look like right now relative to, I'm sure we're down from what we looked like in 1960.
Right.
On a percentage basis.
I mean,
I don't know where we are versus on a global basis, versus any kind of historical timeline, because of course there are a lot of other countries that are in the game now that weren't, in 1960 to some degree.
The demise of,
I would imagine.
I mean, the demise of the Soviet Union totally transformed science funding in this country. And I don't think most people understand that. Tons and tons of basic research were funded in one way or the other through the Defense Department, because there was such a sort of powerful urge to beat the Russians at everything.
Right.
And artificial intelligence is a good example where it was once considered, an important priority for sort of defense purposes to sort of fund real sort of quote unquote real or traditional AI basic research. With the Soviet Union gone, a lot of that money has dried up.
Right, although I wonder whether the Pentagon or the CIA aren't spending a lot of money right now trying to figure out, how to identify, how to improve their positive ID of people who they're about to kill with drones.
Right.
How do we take it from, an educated guess to a somewhat more educated guess of who it is we're killing.
Right.
Would strike me as the sort of thing that would be a big data AI problem that the Defense Department probably would care about.
Right.
And they seem to care a lot about robotics as well for similar reasons. They want, machines that will enhance human capabilities or be able to replace humans on the battlefield to one degree or another.
Right. I mean, one of the sort of perpetual questions that emerges from this conversation is, some people, some very bright people, believe that the sort of divide that I'm talking about will, in the long run, prove to be a false dichotomy. Which, in other words, that there's a chance that the accumulation or the gradual improvement of probabilistic methods will eventually get us to a place where you create or you can replicate the actual sort of theoretical underpinnings that we're talking about. Now, I don't claim to understand those arguments. So there's in their book, in their textbook, Modern AI or AI: A Modern Approach, Peter Norvig and Stuart Russell are very. So these guys, Peter Norvig works for Google now. He's like one of the gods of AI, and one of the things he's very straightforward in saying that it's unclear if that will ever make that leap from probabilistic models to more traditional models. And they have this great line in the book, which is they compare using a probabilistic model to get to a truly sort of a human-like intelligence as being potentially like the man who tries to reach the moon by climbing a tree, which is
right. You get steady progress until you get to the top of the tree.
Right. In other words, one of the things that makes these systems seductive is they are able to report really incredible gains practically. I mean, the systems that I'm talking about are enormously sophisticated, and they're very good at predicting human behavior in some contexts.
Right.
But the question is are we just sort of following that line down as far as it can possibly go, and are we going to find that in fact we can't get to the next stage of traditional AI, of human-like?
Well, let me throw out another possibility, right? Which is that convergence goes the other way, which is to say, it's not that one day we wake up and discover, wow, we finally created a true thinking machine, simply by throwing enough processing power and enough data at a machine designed to mimic general intelligence or mimic human language capacity or whatever. I wonder whether convergence isn't going to go the opposite direction, which is to say that our own minds are going to change because we're going to get more and more used to having the functionality of these probabilistically designed quasi-intelligences as aids to ourselves and as entities that we interact with. So this is not completely conjecture to think that could be true. They've done. I mean, Socrates was worrying about this sort of thing back in ancient Greece with respect to writing. He didn't want stuff written down. He felt that that writing screwed with people's memory and screwed with their perception of language, and was ultimately going to mess up their minds, and it did. If you look at pre-literate cultures, people have studied pre-literate cultures and the way, for example, bards in pre-literate societies in the Balkans, were able to memorize these huge, massive epic texts, and recite them and improvise on them as they recited them and so forth. It's something that is kind of astonishing to a modern person, and that's the effect of writing. You're already starting to see some of the same kinds of changes as a consequence of things like having the internet ready to hand, having things like Google Maps. People have talked about how people's driving skills have changed as a consequence of having GPS and ways in which they are less aware of the environment around them. And people who learn to drive just with GPS from the very beginning are probably not going to acquire the same kind of awareness that someone who learned to drive in the 1960s or 70s or 80s or 90s or whatever would have had to acquire. Matt Crawford has a book out now, The World Beyond Your Head, and a big chunk of that book sort of talks about the changes to our mental relationship with the outside world that are a consequence of the ways in which that relationship is increasingly mediated by technology. And a lot of the things he talks about aren't even things that we're totally directly aware of, like things like the electronics in your car that remove you from a sort of tactile relationship with the road, with the brakes, with and so on and so forth, and that without those signals coming to you, you don't really feel the world around you. I do wonder to what degree this is going to be a revolution in human consciousness comparable to the revolutions affected by nearly universal literacy, by moving from a rural to an urban environment. There have been studies done of sort of the effect on IQ of growing up in a city versus growing up in the country, and it seems to have a significant effect on IQ, by which that seems to suggest that it's not making us, or may not mean that IQ is measuring intelligence in some abstract sense, so much as the ability to deal with certain kinds of problems efficiently that may not track with the kinds of problems that somebody who lives in, in a hunter-gatherer society, let's say, needs to be able to track. Anyway, there's a long-winded statement, but I don't know if you read Crawford's book, or if you thought at all about sort of the way that our minds get changed by interacting with these kinds of electronic artificial intelligences.
So I haven't read Crawford's book beyond one chapter that was sent to me by a friend, and some reviews and stuff about it. But I think the topic is certainly fascinating, and yeah, and I mean, one of the things, so there's this famous, there's a couple famous places in research on the relationship between orality and literacy, which crop up a lot in research and people in my field. And that is, so you can find, for example, letters back when people used to write multiple letters a day. You can find people sort of in the transition to a highly literate society writing things like, I wanted to send you a letter last week, but I lost my voice. Right? In other words, that that like the relationship between orality and literacy was so deeply wedded, and it was so normal to mouth aloud the words that you were writing, that they couldn't conceive of writing a letter without that. So technology is always sort of influencing what we sort of think of as the path of cognition. There's a wonderful web text which we'll link to here, called Satellite Lamps, which is found in a hybrid online academic journal called Kairos. And that Satellite Lamps is all about how GPS has changed people's perception of the cities that they live in, and how there's a whole generation of city dwellers, particularly people who don't grow up in those cities, but who move to them as young adults, a lot of young adults do, whose conceptions of their cities are no longer based on roads and the sort of traditional road navigation as they are through their understanding of through GPS. And it talks a lot about these kind of things. At the same time, there is this sort of fundamental, so yeah, I don't doubt at all that these things alter our cognition. In terms of technology ever truly understanding or mimicking or modeling our understanding, there is this fundamental question you see sometimes, which is called the wetware question. You sometimes see it referred to as, which is the perspective that is that, look, our consciousness emerges from a biological, physiological, carbon-based, water-based system.
Right.
In other words, our hardware is in fact wetware. And it is irrational to expect a silicon-based, transistor-based system. So, I mean, even the most powerful computer chips in the world, not going into quantum computing, still operate on, billions of transistors, of little switches that go from 0 to 1. And some people say we shouldn't expect ever to replicate a kind of thinking that comes from a carbon-based, water-based physiological system on a silicon-based hardware system. And so what some people are, and in its very early infancy, what some people talk about doing is creating an organic or biological computer. Because, I mean, one of the things that we don't even know, and I guess, and I think one of the things that these conversations always lead to is we still continue to have very little understanding of cognitive science, which is part of the reason why it's hard to create a functioning AI. One of the things that we don't know, for example, that information in the brain is sent in particular like discrete packets, right? Like when you look at a computer program, you know that there are certain discrete packets of information that are sort of broken down into bits and bytes and things like that in order for the computer to process it. We don't really know that that's true of the brain, right? Like on these fundamental lessons. There's an analogy that's been made that says, if you compare what we're trying to do with cognitive science to what we do in computer science, if I'm any moderately informed computer scientist, I can open up the case of a computer and I can look at all the parts and I know what the different functions of those parts are, right? So I know that a computer needs storage, so I can look at a hard drive and I can know how that works. I know that a computer needs short-term memory, so I look at the RAM. I know that a computer needs a central processing unit, so I can look at the chip. In other words, I know the functions of the different parts first, and so when I look,
because we built it,
right? We built it. So you look at the
right.
You can look at the function. You can look at the parts, and you already know their function, so the system makes sense. Well, we're
and there are biological systems that we can do that to one degree or another.
right.
Right? So, if you take apart the human eye, right?
Right.
They can, that can be analyzed functionally, and you can follow how the sensory input is transformed as it hits, as light hits goes through a lens and hits the retina, and what comes out the other side into the optic nerve. You can follow that.
Right.
Right? There comes a point where, where we start talking about a consciousness of the light, where we can't really follow the thread any further. But that again comes back to sort of, to what we were talking about what consciousness is. And if you say it's an emergent phenomenon, what is the phenomenon that has emerged?
Right. So in comparison to our computer scientist who can look at the physical architecture of a computer and can know what he's looking at because he knows the different functions the different parts have to fulfill. Imagine you take even a very brilliant person from the 18th century and you lay out the internals of a computer to that person. That person can try to make a scientific and educated series of predictions about what the different parts are for, and they might even succeed at a kind of crude understanding about what different parts do. But fundamentally, because they don't know what the purpose of the different parts they're looking at is, it's going to be very hard for them to understand the difference between RAM and a CPU. And in many ways, we remain that person when it comes to the brain, because we're trying to, in some ways, we're forced to sort of go about it backwards, because we need to observe physiological structures, neurological structures, to try to predict their function, rather than knowing their function and having that explain why their physiology is the way that they are.
Yeah, but I don't think that's anything special about the brain, right? I mean, that's true with any system of any sort that's a sort of a complex, a biological system, certainly. If you're studying how, a pitcher plant works, right, which has no brain at all, right, and you start out knowing nothing, right, it's going to take a certain amount of investigation to learn how the organism grows and its different parts work, and it's a simpler system than the human brain. And I suspect that, I don't know anything about pitcher plants, but I suspect that people who study them know an awful lot about how they work. So I'm not so sure that there's something that makes the brain special. The fact that we didn't design it and therefore we don't know how it works. It is an astonishingly complex system. But I'm a sort of a materialist Mysterian, I guess, which is to say I don't see the need to invoke spooky entities that come from outside the universe to explain, why I can think. But I do think that that consciousness can't be wished away as a problem. It's a deep mystery. And I find myself attracted to the sorts of people like the Roger Penrose types who will assert on the basis of fairly limited evidence that that deep mystery must be connected to other deep mysteries, and who question whether maybe the brain is a quantum computer in some fashion, and stuff like that. I think if you want to talk about sort of like looping back to something you said earlier about is it likely that human-like consciousness would emerge from a silicon-based device? I think there are a bunch of different questions sort of rolled up together, right? In that, right? We are not just brains, right? We're embodied, right? And an awful lot of what our brain does may only be possible in conjunction with what our body does. If you this is something that Matt talks about in his book, that like they did experiments with kittens, and putting one kitten allowed to roam freely and the other kitten sort of put in a little cart and sort of wheeled around, and given a similar, over the course of their first few weeks of life or months of life, whatever, given similar exposure to the world, but one kitten being allowed to interact and the other kitten not being allowed to interact and just being sort of passively observing. And the model of the world that the non-interactive kitten built up was significantly impoverished. The kitten basically couldn't, once sort of let out of the cart, never figured out how to handle existing, how to handle objects and edges of surfaces and things like that. Much of the world was a mystery to it. And you see similar kinds of things with sort of, when they've done studies like feral children and children raised in sort of severely deprived environments, that the brain needs the body's interaction with the world to learn how to make sense of the world in a lot of ways.
Right.
You're also asking a question about whether the kinds of devices that we're building, are the kinds of devices, are architected in a way that is open-ended enough to have an emergent property like consciousness emerge. So maybe it could happen in a silicon device, but it would have to be, it would have to be designed to be as open-ended in its purposes as the human brain is. And then there's, like your question of, maybe there's something about being biological, and we should start with artificial brains rather than with trying to replicate the brain in a different substrate. I don't know.
Have you ever?
Good questions. I don't know the answers to any of them.
Have you heard of the OpenWorm project?
No, I have not. What is the OpenWorm project?
So there's a fantastic, we'll link to it here. There's a fantastic sort of primer on this by Alexis Madrigal, written a couple of years ago from back when he was at the Atlantic. So there is a worm, a sort of microscopic, right? You might be able to see with the naked eye, but it's about 1 millimeter long. It's a little worm, a nematode, known as C. elegans. And this is an incredibly simple animal life form. And it has been studied intensely by people from different scientific backgrounds for many years. And the idea is to sort of to start with an extremely simple organism to sort of understand how we can go on to understand sort of more sort of sophisticated things. Now, so one of the things that's true about C. elegans, I mean, for one thing, it's actually naturally transparent, which makes it very easy to study some of the things that are going on within it. But one of the things about C. elegans is that it has, I think, something like 300 neurons in its brain. And in comparison, the human brain has like 60 billion. So it's got a very sort of simple brain, which would imply a very simple kind of cognitive mechanism going on inside of it. And in fact, we have, so there's this branch of cognitive science.
Although a neuron itself is a lot more complicated than a transistor.
True, right? True, absolutely true. There's this field of cognitive science and neuroscience called connectonomics, which is the idea is studying all of the neurological connections within a particular type of brain in order to hopefully understand more about the cognition that happens in that brain. And so I think C. elegans is the only organism in the world where we understand, where we have mapped out all of its connectome, which is what they call it. The thing is we can completely control its environment. We've sequenced its DNA. We have sort of discovered its connectome or whatever. We have investigated that. And we still can't predict its behavior aside from some very simple ways, right? In other words, with as much kind of scientific and physiological and anatomical and environmental data as we have, we don't understand what's happening inside its little brain. The OpenWorm project is this,
which could mean, right, that there's a lot we don't understand, or it could mean that there's a way in which it's a chaotic system and is just not going to be predictable for reasons that are themselves comprehensible, right? In the same way that the weather is not fully predictable, even though nobody thinks the weather has some spooky intelligence.
Right. Yeah. And I'll so quickly say to everyone that I'm an atheist and a materialist, and but
those are not. You don't have to be both.
No, you don't have to be
an atheist and a materialist.
But I am.
You could be an atheist and a Mysterian non-materialist.
That's true.
You can be all kinds of things.
Right. But for the record, I am. So none of my skepticism emerges from the belief in the soul or anything like that. So the OpenWorm project is basically this really ambitious project to use computers in observation of actual physiological C. elegans, these nematodes, and to try to create from the ground up the kind of good old-fashioned AI in the sense of a nematode artificial intelligence. And one of the points that they make, and I encourage everyone to read this article by Alexis Madrigal, is in order to understand its brain, you have to understand its body too, and you have to connect them up. And so this is the kind of basic research that largely doesn't happen, right? This is exactly the kind of thing of starting at the very most simple and most understood organism you can to try to build and model its cognition, and to start from the absolute ground floor without relying on just probabilistic things. So one of the things that's said in the article is it would be very simple to probabilistically, right, predict behavior of a C. elegans. In other words, to just observe them and to say, okay, it's 99.98% likely that it will do this under this stimulus. But what they want to know is they want to get to that underlying thing. And that is, it's very fascinating and it's very promising to me. But it also, you can look at it and say, number one, it's still so early in the development, and there's still so much work to be done. And again, this is an animal with as simple as a brain as we can imagine, and we eventually want to understand humans. But number two, I'm sure that everyone involved in this project is doing very well for themselves academically, and I'm sure their funding is fine, but you can imagine being a young researcher and, trying to decide, should I pursue this kind of research, which is going to take decades of hard work, and which, along the way, I'm never going to accidentally write an algorithm that I can sell to Google, right? Or do I go in the big data direction? Do I go in probabilistic directions, knowing that that will open up professional boundaries for me, and it will result in probably more opportunity to be funded by a lot of the agencies that require a kind of a practical application. So you can sort of see why
I mean, this is an age-old, as I said earlier, I think this is an age-old problem. And it implicates all sorts of other questions about how our political economy works, independent of the specifics of the particular research program of a particular academic discipline. I want to shift gears for 1 second before we have gone. I mean, we've already gone for a long time, but while we still have a little bit of time, because you were talking at the very top of this whole discussion about some of your work, and I'm interested in the. I'm very interested in the use of, or the feedback loop between the sort of data-intensive analysis of student work and how that feeds back into pedagogy and is changing the way we teach and the way classrooms are run. And I'm interested in your take on that whole phenomenon, and whether and both from a sort of policy perspective and from the perspective of what you've learned from what you do, since it sounds like you're working in that particular area.
Right. So, and this actually, I think, if I can do this concisely, I also think that this really speaks to why these kind of data approaches are popular, despite many people who use them know their kind of limitations. So let me really quickly. So I am an applied linguist, or I consider myself an applied linguist. Most of my coursework has been in applied linguistics or related fields. The application, I mean, one of the major differences between applied linguists and theoretical linguists is that applied linguists tend to look at actual students and actual language users, and to, in the ways typical of the social scientists, try to build up a big enough number of observations, a large enough N, and to observe real-world language use, and to then try to be able to make predictions and observations about how people actually use language in real-world situations. That might seem like, well, of course that's what a linguist would do, but that is out of keeping with the tradition of sort of Chomskyan linguistics that have predominated for the last 50 years. So if you go back to the very beginnings of corpus linguistics, which is in the 1950s, so this is before we had the computer analysis, Chomsky was famously dismissive of corpus linguistics. And again, corpus linguistics just means looking at real-world language samples and trying to derive understanding of language from them. And Chomsky said that, he sort of notoriously said that it is nonsensical to talk about the probability of a sentence, right? Why? Well, because any 5-year-old has the linguistic capacity in their native language to produce a sentence that has never been produced before, right?
Right.
Right now, if you and I
That's
decided,
why Chomsky was looking for universal grammar, basically.
Right. So what Chomsky says is that we don't cognitively understand language, at least not at the most basic level. One of his famous aphorisms is, "A child learns language the way a bird learns wings," which in other words means that our language is instinctual, our capacity for language is instinctual, and that is part of our genetic endowment. We're born with it.
It's a hardwired capacity.
Right. Now, the actual sort of, we call a cow, and another language calls it something else. The actual sort of details of the language are social and cultural and produced from that.
Right. Now you're into historical linguistics rather than...
Right. Yeah. But what's really important to linguists in the Chomskyan formulation is that we have this sort of underlying structure, this universal grammar. And that what a serious linguist should do, and what Chomsky does, and what his many, many, many followers do, is look for that universal grammar. And that's what the field of syntax is about, and a lot of other sort of related fields. So why, if that's the case, then why would someone like me bother to go around and try to invest lots of resources and time and pull out my hair trying to get enough research subjects? The problem is that we've been trying to build a theory of universal grammar, like I said, for half a century. And I have many syntactician friends who will not be happy with this statement, and but some other friends who will agree with it, which is the project to find universal grammar seems to have stalled. We still know very little about this sort of underlying universal grammar that all languages supposedly share. For someone like me, so again, I'm here at this university where it's my job to teach people, real-world language users, to use language in a more productive way. I can't wait for the Chomskyans to finish the project of minimalist syntax or generative grammar, or whatever you want to call it, before I sort of tell a Chinese student, here's how you can use language a little bit.
Well, right. Rather the way that Google can't wait for us to solve the riddle of consciousness before trying to figure out how to teach a car to drive itself.
Right.
So they've got data, they're going to use it. That seems to produce results.
Right.
So you similarly, you need results. You need to be able to do a job.
Right. So
you can't wait for the theoretical solution. You need a practical solution.
Exactly. So after 50 years, it is not clear that universal grammar exists in the way that we have traditionally thought it exists. And so, people like me say, okay, well, I can't figure out what the underlying cognitive pattern of our fundamental language capacity is. But what I can do is, and what I'm assisted in doing now in the digital age, is looking at how actual real-world language users have really used language. And so I will take a very big corpus set, millions of words of things produced by actual learners. And so, like a classic example is, I will use a program that can analyze a language sample, a written language sample, along a whole variety of lexical and syntactic features, and it can spit out. And then I can sort of results, and then I can compare it to how these different students do in their language use. So I'll have rated language samples, like say a 6 will be the best sort of sample, a 1 will be the lowest. And I'll say, okay, what is the relationship between, for example, mean clause length to their score? What is the relationship between the diversity of their vocabulary and how well they are perceived to use language, things like that. And you add more and more things into these models, and hopefully, eventually you say, okay, the students who do a really good job of speaking English as a second language are the students who do X, Y, and Z. And the students who struggle don't use X, Y, and Z well. So now when you go into the classroom, you want to choose a language plan that focuses on X, Y, Z. And conversely, we found that A, B, and C don't really contribute that much to how effectively they use language. So let's minimize that in the classroom. The degree to which that's actually happening now in terms of this research informing direct pedagogy is limited. There's this,
Right.
It takes forever for things to move from the research literature to the classroom. Where it's really
Well,
coming into play is in automated assessment. So, in other words, computer programs that look at student writing and assign it a score for tests that have high stakes. In other words, the cutting edge of
right.
this stuff is not in the classroom. It's companies like Pearson or ETS developing systems to analyze language samples automatically because it's cheaper to do that, for the computer to do it, than to hire humans to do it. Now,
Right.
I would say that that's the opposite of what we want from a sort of a fairness perspective and a social perspective. We would want it to inform pedagogy first and then eventually see if it can do this. But again, the profit motive kind of motivates that.
Well, I think you're absolutely right. That's one place that it's being used heavily. It is worth pointing out that both in the regular school system and particularly in sort of high-performing charters, that feedback loop, well, or the use of sort of frequent and extensive assessment, with the goal being to have it feed back in some fashion, is a burgeoning phenomenon, and there are very widely divergent opinions out there about whether it is a good phenomenon, a terrible phenomenon, or sort of a mix of both. I count myself in the mix of both camps. I was actually involved in the creation of a charter school. I was on the board of it a number of years ago, and it was an interesting learning experience. I think I have a more complex view of the charter landscape now than I did when I first set out to do this. But one of the hallmarks of that school and of a lot of the schools that it was modeling itself on is precisely having that kind of a feedback loop, having a lot of what I would call sort of continuous low stakes testing,
right?
With a view to feeding back into the classroom, and having, being able to say not just, okay, this module doesn't seem to have worked, but this module doesn't seem to work with these students who have these kinds of issues, or this module doesn't seem to work with this particular student, or this teacher doesn't seem to really know how to use this module, or whatever. But having sort of a robust enough data set to be able to get to that level of granularity.
Mm-hmm.
What I feel like has happened and I think there's a lot of value to that. What I feel like has happened in the regular school system is more that it's being used without the feedback loop part. Right. So what's happened is instead pedagogy itself has changed dramatically in the public school systems that have gone in this direction, and frequently under federal pressure, to the point where we're losing sight of what pedagogy is in the first place. Right? Pedagogy is turning into a kind of, well, we're trying to get this result on the assessment, rather than.
When you say this kind of when you refer to a kind of continuous data collection, that doesn't, I would avoid the word test to refer to that, because one of the things that we can do, that's possible to do, is you can collect data from regular classroom practice, and you can learn things about your students and how they're improving or not improving without having to have the kind of disruption that comes from 2 weeks out of every year of just pure standardized testing, which was a low estimate for a lot of public school students now. The problem with that is,
I think, these days.
Yeah, the problem is that it is not to the financial benefit of companies that provide testing materials to have that kind of model. In other words, part of the reason why we have this kind of frantic teaching to the test and then standardized testing and then getting the results back and saying, oh, you better improve this score, you're in trouble, and then more frantic teaching to the test. That is a model that is very profitable for the right people. One of the things that really bothers me about the ed reform movement is we have the power of inferential statistics. In other words, the whole purpose of a lot of these systems is to be able to derive from fairly smaller numbers of people, right? We can take a few thousand kids, and if we are careful with our sampling, if we're careful with our statistics, we can project results onto millions of students. So we have the statistical ability, to make very accurate predictions about how students will behave based on much smaller data sets. But the model in the ed reform movement is test everybody and test them all the time, which is maximally disruptive and maximally and has sort of maximum negative consequences for pedagogy in the way that you identify.
Well, I think it's sort of ironic. It's a comment I've made a number of times to people in the ed reform movement. It's ironic that a lot of the things that have been imposed in the name of education reform on the regular public school system are substantially at odds with what the sort of best practices schools that the ed reformers champion in the alternative, in the charter sector, do.
Right. I mean,
I've never gotten an adequate answer as to why that would, like an ideological answer as opposed to you're giving an answer based on, what amounts to a corrupt motive. But I've never gotten an answer that was very satisfying to me.
Well,
about what that is actually sort of defending it on the merits. Honestly.
Right. I mean, as someone who, my dissertation was about a standardized test. I do a ton of work with standardized tests of language and learning, and I am a skeptic and a critic of many of those tests. One thing that we do, even speaking as a skeptic and a critic, one thing that we can do fantastically well, one thing that we have the ability to do, is to extrapolate from a smaller data set and be able to make very sophisticated and accurate predictions onto larger populations from those data sets. And that is precisely the advantage that the current testing mania avoids. What I would say is the biggest benefit is the one that we are least likely to do because of an ideological attitude that we have to test everybody for some reason. So,
well, I mean, there are again, sort of bracketing what you identified as again what I would call sort of a corrupt motive. I think there are ideological reasons that people will give for testing everybody, and not to put too fine a point on it, but one of the reasons is that some of the most confident predictions you can make are exactly what the ideology of the day says the school is supposed to break, right? Like if you look at race and socioeconomic status and education of the parents and a whole sort of list of factors like that, you can make some very confident predictions about performance. And the promise of public education is, none of that is going to matter, right? We're going to give everybody and a quote-unquote equal shot. And I think there are a lot of there are a lot of predictable ideological reasons why we have wound up, as a society, proclaiming loudly something that, if we think about it, we kind of all know is not true, which is that, yes, the schools can solve all of those disparities and everyone will get, if only we got the schools right, everyone would get a perfectly equal shot. So if you start from the proposition, what we're trying to do with the schools is get it right so that these predictions won't be valid anymore, then it's a little more difficult to pursue statistical analysis of the sort that you were describing.
Right. And of course, from that perspective, getting it right means firing teachers.
Well, that's one thing it means, right? I mean, I don't think that's the only thing that ed reformers advocate is firing teachers.
No, but I mean,
but one thing.
Part of the reason why people want to test every student or every classroom is because they want to know which teachers to fire, which is one thing that you can't do by, like, if you look at the NAEP, the National Assessment of Educational Progress, which is the gold standard of educational testing in this country. One thing that you can't do with NAEP data is identify specific teachers to be fired, right?
Right. But you don't actually need. So this again, right? If you wanted to be able to fire teachers, you wouldn't need to test everybody. All you would need to do is give principals the authority to fire teachers, then give politicians the authority to fire principals or whatever, right? Like you can impose whether or not it's a good idea. You could say it's a bad idea, or you could say it's a good idea, but you definitely don't need some kind of, test. You could just tell the foreman, fire your worst worker.
Right. Of course, the problem is...
And let the foreman decide who the worst worker is. And if the foreman winds up with poor results, then fire the foreman.
Right. Of course.
Right? That's...
Part of the problem. Part of the problem with that, and this is part of the problem with things like merit pay and things, is that who the principal identifies as the best teachers and who the test identifies as the best teachers are often wildly divergent. But anyway, this is a big can of worms.
As I'm sure is also the case at General Motors.
Right.
Right. That, who your bros... I mean, that's... Fundamentally, you're trying to impose a corporate model on the grounds that a sort of we know that the corporate model, quote unquote, works, right? Because capitalism continues sort of to operate. And the problem is that what you're really doing is importing a bureaucratic mechanism from the corporate world, where in the corporate world, the profit motive, right, the fact that there is a bottom line imposes a sort of objective discipline. Not perfectly by any means, but everyone knows what it is.
Right.
Right? Whereas once you take that motive out and say, okay, well, we're going to try to use the same kinds of bureaucratic processes, but it's not obvious what this objective thing is we're measuring. That's sort of the where the rubber finally meets the road and we face reality. There's huge incentives to corrupt the process, and not just in the way you were talking about with the motives of testing services themselves. I mean, politicians have lots and lots of ability to manipulate these kinds of statistics and lots of incentive to do so.
Right.
And by the time you find out that they've been manipulated, it's someone else's job.
Well, maybe
that never happens in the corporate world, but over the whole ecosystem, there's some discipline from the fact that companies will go bankrupt if everything is corrupt.
Right. Well, maybe to bring this full circle and close up, then I think one thing that is ahead of us, I think a lot of people believe that in the future, decisions like hiring and firing and promotion will be handled purely algorithmically in some places. That there's some companies that are going to say, well, we're going to get objective and let the data tell us, and they'll develop algorithms to sort of decide who gets promoted and who gets let go. And I think something like that will happen in the next 50 years in many industries. The problem is that
there are places that already operate that way. There's a hedge fund in the New York area. I'm trying to remember the name of it. That aspires and is doing their darndest to reduce every single thing to a objective formula, and that just sort of reflects the sort of autistic personality of the founder, more than anything else.
Well, then that's the thing is
their results prove that this is better. It does prove that certain people who can't adapt themselves to this crazy way of operating don't stay at that fund very long.
Well, that's the thing, and I think that one thing that will happen is I think you will see real morale problems in firms when there's a big discrepancy between the people who identify their coworkers people who are identified by coworkers and superiors as good workers, and who the computer does not identify as good workers, because human psychology and morale exists. I think that's something. I think that's a conflict that is brewing and will happen soon. So we'll see.
Yeah, I mean that's what you're talking about is, sort of the next step. What you're talking about is tailorizing, human resources on some level, right? And the big downside of the creation of the factory system from the beginning is it produced all of these efficiencies, but it was a fundamentally inhumane way of running an organization and fundamentally inhumane approach to work.
Right.
I think Matt Crawford would agree with me, since he's on a sort of one-man crusade to convince people that the crafts are not just for people from Portland or Brooklyn, but matter to all of us. Right.
Hey, it's been great talking to you, Noah. I really appreciate the opportunity.
My pleasure. I appreciate the opportunity as well. I've been hoping to do this for a while, and I'm glad we finally did.
Yeah, me too. I'll talk to you soon.
Take care.